Hi friends, welcome to my YouTube channel. Today I'm going to explain about design logic gates by using multiplexer. So multiplexer is nothing but is a data selector. It has 2 power n inputs and it has one output. So out of 2 power inputs, so we have selecting only one input. Depends on the selection. Depends on the selection. So my aim is how to design the logic gates by using multiplexer. We have different logic gates are there, right? We have 7 logic gates. So 3 are basic gates, 2 are universal gates, okay, 2 are special gates. I'm able to design how to implement these gates by using multiplexer. So first of all, I'm going to design both the NOT gate by using 2:1 multiplexer. Okay. So ఎలా చేద్దాం చూద్దాము. NOT gate using 2:1 multiplexer. Let's see. So multiplexer has two inputs, right? This is called as I naught, this is called 0, this is called 1, and we have one selection line, one output. So how to design the multiplexer? First of all, you can draw the truth table. It has one input, one output, right? This is a NOT gate, right? As you know, NOT gate, it is A, output is Y. So whenever the input is 0, output is 1. Whenever the input is 1, output is 0. So 0, output is 1, 1 is given, output is 0. I consider, so it is the selection line, right? I consider A equal to S equal to A. I have given the one input is given to 0 and the one input is 0 input is given to the one control signal, one logic one, right? What is Y? So Y equal to, you know, right? S bar into A plus S into B. This is the logic, right? Suppose it's considered something A. Okay, this is something A, this is B, right? So you can substitute S bar. So what is this? Nothing but S bar, right? The A bar into 1 plus A into 0. This becomes A bar into 1 is A bar plus 0. Then Y is equal to A bar, right? Now, as per your logic, Y equal to A bar. వచ్చింది కదా? సో ఇలా మనము డిజైన్ చేస్తాం. సో కంపల్సరీగా 0 ఇన్పుట్ 1 ఇవ్వాలి, 1 కి ఏమి ఇవ్వాలి? 0 ఇవ్వాలి. అలానే మనము AND గేట్ డిజైన్ చేద్దాం. AND గేట్ బై యూజింగ్ మల్టీప్లెక్సర్. ఎలా చేద్దాం చూద్దాం. సో ఇక్కడ చూస్తే we have two inputs AB, one output Y. So as per the AND gate, right? 0 0 0 1 1 0 1 1 and we have four outputs, right? So 0 0 AND gate means if two inputs are 1 then output is 1. చూడండి ఇక్కడ మనం ఏం చేస్తామంటే ఈ టూ ఇన్పుట్స్ లో మనకి ఏంటి మల్టీప్లెక్సర్కి ఏం కావాలి? ఒకటి కంపల్సరీ సెలక్షన్ లైన్స్ కావాలి. నేనేం చేస్తానంటే ఏ ఈజ్ ఆల్వేస్ చూస్ యాజ్ సెలక్షన్ లైన్. సో ఏని నేను సెలక్షన్ లైన్ తీసుకున్నాం. సో టూ కాంబినేషన్స్ ఏమున్నాయి? జీరోస్ ఉన్నాయి. టూ కాంబినేషన్స్ ఏమున్నాయి? 1 ఉన్నాయి. సో ఇఫ్ ఏ ఈక్వల్ టు 0 ఉంటే సో B is 0, output is 0. B is 1, output is 0. This means in constant ఏమొస్తుంది? Whatever the input B is either 0 or 1, constant output is 0 should be 0. If consider the next combination, if A equal to 1 ఉంటే, like selection line లాగా A equal to 1 ఉంటే ఏమొస్తుంది? 0 ఉంటే 0 వస్తుంది, 1 ఉంటే 1. అంటే ఏంటి? B. So Y is nothing but B. That's why by first input 0, next input 1. Whenever A equal to 0, so 0 has to be transferred to Y. If A equal to 1 means so B is transferred to Y. This is about the logic. Okay, right? So this is the way you can design the AND gate by using 2:1 multiplexer. Right? నేను కావాలంటే ఇప్పుడు A equal to 1 తీసుకున్నాను. I am taking the A equal to 1. Let me check whether my design is working. A equal to 1. I have considered B equal to 1. So let me substitute B equal to 1. A equal to 1. The B is only transferred to Y. Right now what is Y? 1. That's why output is 1. Like this. If I change A equal to 0, B equal to 1. So see, B equal to 1, A equal to 0. A equal to 0 means, so this is one connected, right? That's why the output should be 0. As per this condition, A equal to 0, B equal to 1, output should be 0. This is the way you can implement the gates. Similarly, you can design that OR gate by using multiplexer. Again, you will take the two inputs to the table, then Y, 0 0 0 1 1 0 1 1. మనకి ఎప్పుడు కూడా ఏం తీసుకోవాలంటే ఒక ఇన్పుట్ ని సెలక్షన్ లైన్ గా తీసుకోవాలి. సో 2:1 మల్టీప్లెక్సర్, రైట్? సో నేను ఏని సెలక్షన్ లైన్గా తీసుకుంటున్నాను. సో రిమైనింగ్ ఇన్పుట్స్ నేను బిలో చూపిస్తాను అనమాట. చూడండి 2 కాంబినేషన్ 0 0 వాట్ ఇస్ కరెస్పాండింగ్ అవుట్పుట్ 0 1 1 1 రైట్. ఏమొస్తుంది? సో ఈవెన్ ఏ వాల్యూ 0 ఉంటే బి వాల్యూ 0 కానీ 1 కానీ ఉంటే ఏమొస్తుంది మనకి? సేమ్ 0 1 వస్తుంది. అంటే ఏంటి? బి. ఇఫ్ నెక్స్ట్ వన్ ఏ ఈక్వల్ 1 ఉంది అనుకోండి, నెక్స్ట్ 0 ఇచ్చినా 1 ఏమొస్తుంది? 1 ఇచ్చినా 1 వస్తుంది. దిస్ మీనింగ్ ఎంత? కాన్స్టెంట్ అవుట్పుట్ ఇస్ ఎంత? 1. దట్స్ వై దిస్ ఇస్ అబౌట్ బి. ఫస్ట్ ఇన్పుట్ వెన్ 0 బి, second input when a equal to 1 means constant 1. This is about the OR gate by using 2:1 multiplexer. సో మనము ఇది s ఈక్వల్ 0 కండిషన్ తీసుకోవాలి, ఇది s ఈక్వల్ 1 గా తీసుకుంటాం అంతే. 0 ఇచ్చినప్పుడు y అనేది b అనమాట. y అనేది ఏంటి? b. సో 1 ఇచ్చినప్పుడు ఏంటి? y అనేది ఏంటి? ఆబ్వియస్ గా 1. సో నెక్స్ట్ వన్ NAND gate. One is NAND gate by using 2:1 multiplexer. ఎలా చేద్దాము? Same as this. So you should remember the truth tables. A, B, we have one output y, 0 0 0 1 1 0 1 1. Output NAND gate enti? Exact opposite of the AND gate, right? And two inputs 1, output is 0. Remaining all are 1s. So you take the two input multiplexer. So have keep selection line as A. This is it. Two combinations 0 0 is 1 1 is 1 means whatever the input is 0, what is our input is B, either 0 or 1. Constant output is 1, right? And coming to the second condition, whenever A equal to 1, so B is changed to 1 and 1 is changed. This means enti? Y is nothing but B bar. Complement 0 becomes 1, 1 becomes 0. That's why the first input is 1, the second input is B bar. This is about the 2:1 multiplexer. Design NAND gate by using 2:1 multiplexer. The same way, you can also design that NOR gate. Okay, NOR gate. A, B, we have one output Y as this 0 0 0 1 1 0 1 1. మనం ఏం చేస్తామంటే 4 కాంబినేషన్ 2 కాంబినేషన్ డివైడ్ చేస్తాం. ఎందుకంటే సెలక్షన్ లైన్ అనేది 2 పాసిబుల్ కాంబినేషన్ ఉంటాయి కాబట్టి 0 కాబట్టి 1 కాబట్టి. సో ఫస్ట్ ఏం తీసుకున్నాం? యాజ్ దిస్ A సెలక్షన్ లైన్, we have one output Y. So what about NOR gate? So exact opposite OR gate, right? So this is 1, remaining all are zeros. Tell me, so when A equal to 0, so 0 becomes 1, 1 becomes 0. This means enti? Y is enta? B bar, right? So whenever in the when, so 0 ichina 0 వస్తుంది, 1 ichina కూడా 0 వస్తుంది. Meaning enta? Y is default 0. Whenever A equal to 1, this is about the NOR gate by using multiplexer. The same way, you can also design that XOR gate. XOR means it has two inputs 0 0 0 1 1 0 1 1. So what is XOR gate logic? When both inputs are different, output is 1 right now. Let me tell you. So this is a 2:1 multiplexer. We have selection line A is selection line. So two constants, A value, we have one out. Tell me, when A equal to 0, 0 becomes 0, 1 becomes 1. This is nothing but Y is as is B. What about other condition? 0 becomes 1, 1 becomes, this is nothing but complement, right? B bar. This is about the XOR gate. Okay. So this is 0, this is 1. You can write what expression? A bar. This means A bar into B. This is A bar into B plus A into B bar. Right? This is the expression of XOR gate. And finally, XNOR gate. Right? We have two inputs A, B. We have one output 0 0 0 1 1 0 1 1. Right? Let me take XNOR means if two inputs are same, output is 1. Again, take two input XOR gate. We have two possible combinations. When S equal to 0, we should consider A 0 0 0 becomes 1, 1 becomes 0. What is the relationship between inputs and output? So the Y is nothing but B bar, right? Whatever when A equal to 1, the 0 becomes 0, 1 becomes 1, which is means Y equal to B, right? This is called Y. 2:1 multiplexer. What is the combination? Y equal S bar. That means A bar into B bar plus A into B. So this is about the XNOR gate. So the next video will discuss about the next topic. Thank you.